Thank you once again for joining. Right, so we're going to look at a past paper, as I said in the announcement, that we're going to look at a past paper from 2016, November 2016, a question on probability. Let's go. It says given 9.1, the probability of A to be 0.2, probability of B 0.5, the probability of A or B 0.6, where A and B are two different events. Now, as I mentioned before, this can also be written as the probability of A, or this means or B, right? Equals 0.6. Do we all agree with that? Okay, yes, sharp. So let's get into it. Remember, you're free to ask questions. You can either speak into the mic and ask the question, or just type your question and I'll just get to see it on my side. And then, yeah, you're free to ask questions in any language you're comfortable in. You can ask in Sepedi, English, Afrikaans, doesn't matter. Okay, so let's start with question 9.1.1. It says calculate the probability of A and B. Do you guys also agree with me that this can also be written as the probability of A, this symbol here, probability of B, like that? Are we happy with this? This and this is just one and the same thing. And mathematically is written like so. Or mathematically is written like so. Happy? Thumbs up if you're happy. Quickly. Proper stuff, proper stuff. So now let's go ahead and find the probability. So we know the classical probability formula for two events, the probability of A or the probability of B equals the probability of A plus the probability of B minus probability of A and B. Remember, what we're looking for is this probability over there. So we're going to substitute all that's given and then make this the subject of the formula. All right. So let's go ahead and substitute what's given. We are given the probability of A or B to be 0.6 there. So we're going to substitute that with 0.6. We're given the probability of A to be 0.2. We substitute the 0.2. Plus, we are also given the probability of B to be 0.5. And then this is what we're looking for, the probability of A and B. Right? So let's go ahead and simplify. We've got 0.6 equal to 0.2 plus 0.5 gives us how much? 0.7. You don't need a calculator for this. You just simply add the 5 and the 2 there. Easy peasy. Minus probability of A and B. Okay. So the aim is for you to have the probability of A and B on one side and everything else on the other side. And you also want to have it to be positive. So you can rather take this to the left hand side so that it becomes a positive probability of A and B equals 0.7. Keep this 0.7 on the right hand side and take this 0.6 to the right hand side. And when we do that, it becomes a negative 0.6. So therefore, the probability of A and B equals 0.1. Are we all happy with the calculation? All of us are happy? All right, proper stuff. Thank you, Patty, for joining. Specky, thank you for joining. Okay, fair. Let's push number 42. We go to the next question. The next question says 9.1.2, are the events A and B independent? Show your calculations. As I said in the introduction, two events A and B are independent if the probability of A and B equals the probability of A times the probability of B. So if you find the probability of A and B to be a certain value equal to the product of probability of A and B, then you'd have proven that the two events are mutually exclusive. Now, let us start with the probability of A and B. We've already found that just now. So the probability of A and B equals 0.1. Okay, that's fine. So now we're gonna multiply the probability of A and B and see if we this gives us the answer of 0.1. If the product of these two gives us the answer of 0.1, it means that the two events are independent. If it's not 0.1, it means that the two events are not independent. Are we clear with that? Class, confirm? Speak into the mic, please. All right, everybody's happy. All right, let's go ahead and find the probability of A times the probability of B. Where we have probability of A times probability of B equal to, we are given that the probability of A is 0.2 while the probability of B is 0.5. Let's see. Let's multiply those two. 0.2 times 0.5 gives us an answer of 0.1. So this probability of A times B equals the probability of A and B. So therefore we can safely conclude that events A and B are independent events. All happy. Why? You must give a reason why. Because the probability of A and B equal to probability of A times the probability of B. All happy. Any questions? Okay. We are all happy. Okay, let's push. Okay, next question. Okay, before we move to the next question, 9.2, I also want to touch on something. If that asks you if these two events, if that asks you whether or not these two events are mutually exclusive, what would you do? Ne? So remember, two events are mutually exclusive if you can choose one of the two. If the probability of A and the probability of B is 0, or the probability of A or B is equal to the probability of A plus the probability of B. So this is the two conditions for mutually exclusive events. Okay, I'll repeat the question. If in an exam they ask you if two events A and B are mutually exclusive, you can either use this to determine that or that. Okay, so if you find that the probability of A and B equal to 0, then you can safely conclude that the two events are mutually exclusive. Or if you can find that probability of A or B is equal to probability of A plus the probability of B, then you would have proven that the two events are mutually exclusive. Either one of the two, ne? Yes. Now, can you guys tell me if these two events A and B are mutually exclusive, given the information we have here? Are A and B mutually exclusive? Confirm. Are A and B mutually exclusive? Events A and B are not mutually exclusive because the probability of A and B is equal to 0.1, is not equal to 0. So that's how you conclude. Ne? Sharp. So now we're going to move to question 9.2. As you can see, the question tests you on the so-called Venn diagrams. Ne? So I want to do a quick summary of this so-called Venn diagrams. Let's do that quickly. Venn diagrams. I'm gonna do that summary. Once we're done with it, we're gonna come back and answer this question over there. Ne? So remember, these questions are from a past paper from 2016. Ne? Sharp. So let us look at Venn diagrams quickly. Okay. Let's just create a scenario here. Ne? You've got three different schools. You've got school A, school B, and school C. Now, in school A learner can either play soccer or netball. The number of learners playing soccer in the school is 5, while the number of learners playing netball in the school is let's say 7 instead of 5. Let's just say 7, and then the number of learners. No, let's keep it at 5. Sorry about that. Keep it at 5. Let's keep it at 8 Okay, so the number of learners playing soccer in the school, soccer, is 5, while the number of learners playing netball in the school is 8. Can you guys tell me what is the total number of learners in this school A? Quickly, the total number of learners in school A. Let's talk. Let us talk. What is the total number of learners in the school? Please speak into the mic. Don't be shy. Don't be afraid. Please, please, please. Nkosnati, Amo, what is the number of learners in the school? The total number of learners in the school. School A. 13, yeah? It is 5 plus 8 gives us 13. Okay. Now let us go to school B. School B, we've got 3 learners playing soccer. We've got let's say 6 learners playing netball and 2 learners playing both soccer and netball. You guys see this? So we've got the number of learners playing soccer in the school, number of learners playing netball. So this is soccer, okay? And this is netball. So now the number in the middle, the intersection, is the number of learners who play both soccer and netball. Does that make sense? Yes. So now, and then this 3, or this, let's put it this way, this area here is for the number of learners playing soccer only, and then this area here is for the number of learners playing netball only. Can you guys tell me how many learners play soccer only? Nice one, Katlego. Nice one, Katlego. Thank you for that, Katlego. Welcome over, gang Moabi. Okay. Katlego's here in full force. In full force. Tsepang Huang is also here in full force. Can you guys tell me from school B how many learners play soccer only? 3 learners play soccer. Soccer only. Okay. Now the next question is this. How many learners play soccer in school B? Not soccer only. How many learners play soccer? 5, ne? Yeah, so it's the 3 and the 2. So 5 play soccer. Not soccer only, soccer. Okay, proper stuff. Now let us move to the next one. How many learners play netball only? 6, yeah? So remember I said that this region here, this area, is for the learners who play netball only. Okay, so we've got how many? We've got, let's write in black, we've got 6 learners who play netball only. Okay, then how many learners play netball? 8. Yes, because the total number of learners playing netball is which area? It is let's go back. It is this whole area, this one. It's netball. So it's 8. 6 plus 2 gives us an 8. Okay, 8 play netball. Not at netball only, but netball. Okay, fine. Now, lastly, what is the total number of learners in school B? What is the total number of learners in school B? 11, yes? Proper stuff, because we go 3 plus 2 gives us 5 plus 6 gives us A11. So who's got a question? Matsimela, you've got a question. Karabo, you've got a question. Ria, you've got a question there. If you understood, please show by way of a thumbs up. Tano, if you understood, show by way of a thumbs up. Sapang, Gosnati, if you're happy, show by way of a thumbs up. Okay, proper stuff. Okay, let's move. Now the last scenario, we've got a school there, school C. Okay, we've got certain number of learners playing soccer, certain number of learners playing netball. They tell us that 5 learners, let's make it a different, 4 learners play soccer, 5 learners, or let's say 6. 6 learners play netball, okay? And then they put a 3 day. Okay, now my question is, how many learners play soccer? It's 4, ne? Okay, and then how many learners play soccer only? Still 4, because we have no intersection. How many learners play netball? How many learners play netball? 6, yeah? Yes. And then if I say how many learners play netball, only still the same thing. Now, how many learners um, um, or rather give me the number of learners who don't play soccer nor netball. 3. Okay, I didn't phrase the question correctly, but yeah, you guys get the point. 3. So what is the total number of learners in the school? 13, yeah, because she went 6 plus 4 gives 10 plus 3 gives us 13. That's the total number of learners in the school. And in school A, it is 5 plus 8. In school B, it is 3 plus 2 plus 6. Sharp. We're still on school C. Can you guys tell me, if I were to pick a learner randomly from school C, what is the probability that the learner plays soccer? So 4 over 13. Okay, so now how do we get this? You guys remember that the formula for probability is the number of favorable outcomes over the total number of outcomes, number of possible outcomes. Okay, so if I ask you what is the probability under school C, what is the probability that if I choose a student at random, that student plays soccer? So you're gonna follow this formula, the number of favorable outcomes. So we're looking for the number of students playing soccer. That is 4. I'll put 4 over the total number of learners in the school. It is 4 plus 6 plus 3, which is 13. Let's move. What is the probability that if a student chooses at random from school C, what is the probability that the student plays neither soccer nor netball? A student is chosen at random from school C. What is the probability that the student plays neither soccer nor netball? Or what is the probability that the student doesn't play soccer, doesn't play netball? Speak into the mic. Or type. Just type there. Feel free to type. My question is, if a learner is chosen at random, so just pick a random learner from school C, what is the probability that the learner plays neither soccer nor netball? What is the probability that the learner does not play soccer and does not play netball either? Yes. No netball, no soccer. Let's just say, how do I represent this? Neither soccer no netball. It is 3 over 13 because we've got 3 learners who are not playing soccer no netball, and another total of 13 learners in the school. Let's just do this last one here. Consider school B. Yeah, school B, remember, has soccer and netball. Okay, sharp. Then we obviously have, I'll just do a quick summary there. We obviously have 5 learners who play soccer in total, so it's a 3 and a 2. And how many learners play both soccer and netball? It is 2. It is this, because it falls under netball and soccer at the same time. But how many learners play soccer only? It is this region here. It's 3 learners. How many learners play netball only? It is this region. It is 6. Okay, now a student is chosen at random from school B. What is the probability that the student plays both soccer and netball? Come on. What is the probability that the learner plays soccer and netball? It is 2 over the total number of learners, 11, yes. So how many students play both soccer and netball? We've got 2 students. So put the 2. And what is the total number of learners in the school? 3 plus 2 plus 5 gives us 11. Okay, let's do another probability. What is the probability that a learner chosen at random from the school plays netball only? Let's talk. Type if you like. Type if you like. Yeah, it says 6. Mahadi says as well, says 6 over 11. Who else has said 6 over 11? Who said that? Is it Tapang, Huing, or Tano, or Amo? Okay, it's fine. 6 over 11, yeah? That's the correct answer. 6 over 11. Proper stuff. Why? Because we know that there's only 6 learners who play netball only. So we're going to put 6 over the total number of learners, which is 11. Now, last question. What is the probability that a learner chosen at random plays netball? Not netball only, but netball. Quickly answer the question. Remember, they're also testing you on speed in exams, ne? Yes? 5 over 11. Did I say netball only, or did I say netball or soccer? Sorry about that. Did I say netball or soccer? I said soccer, ne? What did I say? Okay, let's go again. Let's go again. What is the probability that a student chosen at random plays netball? Try again. 8 over 11, yes. Why? Because we know that this is the total number of students who play netball. That is 6 plus 8 gives us 11. 6 plus 2 gives us 11. 8 over 11. Sharp. So you guys are happy with the so-called Venn diagrams, I get? Yes. Remember that I'm recording this session. I'm gonna post it. I'm gonna post it on TikTok and also on YouTube, ne? Over the next 24 hours. Okay. So yeah. And yeah, let's do like an exam style question on Venn diagrams, just so we can see if you understood what happened there. Let me just quickly clear the space here for the sake of neatness. Okay, let's zoom in. Sharp. So we are on question 9.2. 9.2. Let's read the opening statement. It says a survey was conducted amongst 100 learners at a school to establish their involvement in 3 codes of sport: soccer, netball, and volleyball. So we understand the opening statement. You must always understand the opening statement. So the school has 3 codes of sport. It's soccer, netball, and volleyball. The results are shown below. So basically, let's just say the principal, among the 100 learners, wrote down the number of learners who played soccer, netball, and volleyball, and those who didn't play any of those sports. So now let's look at the results. They tell us that 55 learners play soccer, 21 learners play netball, 7 learners play volleyball, 3 learners play netball only, 2 learners play soccer and volleyball, 1 learner plays all 3 sports. The Venn diagram below shows the information above. Now, let us connect this given information with the Venn diagram. Now, how to connect like this information in the Venn diagram is you must always start with the intersections. So that is intersections, I mean these things like where you have the number of learners who do all sports like soccer, netball, and volleyball at the same time. You start there, and also the smaller intersections. You look at the number of learners who do both soccer and volleyball. You also look at this intersection, this one, which means the number of learners doing volleyball and soccer at the same time. Do you understand what's going on here? Yes, no? Please confirm by way of a thumbs up. Show a thumbs up if you understand what's going on there, please. Okay, proper stuff, proper stuff. Okay, everybody understands on the comment section, and also there's a thumbs up there. I appreciate that. Sharp. So now I want to quickly do a young summary one more time. Okay, this let's this region here, this one means the number of learners who do all three sports: soccer, netball, and volleyball. Why? Because all of the circles sort of cover the one. Okay, remove. Now this region talks about the number of learners who play both soccer and netball at the same time. Do you guys see this region? So the number of learners playing soccer and netball at the same time is A plus 1. A plus 1. Are we happy? Yes? Please speak. Let us also look at this region. This region is the number of learners who play both soccer and volleyball. The number of learners is B plus 1. Are we happy? Proper stuff. Sharp. Then let me just highlight one more. This region here talks about the number of learners who play both volleyball and netball at the same time. It's 1 plus 2. It's 3 learners who play both netball and volleyball. So okay. And then lastly, this region, is a number of learners who play netball only. And this connects with this. You see, 3 learners play netball only. You see, it connects with it. Yes, yes, yes. Any questions? Any questions quickly? Thank you, Sino Tile, for sharing the session. Amo, are you fine? Katlego? Are you cruising nicely? All right, proper stuff. Sharp. So yeah, let's get into it. And then they didn't tell us the number of learners who play soccer only. They didn't tell us the number of learners who do volleyball only. But we're gonna find out as we work out this. And then lastly, the number of learners who play neither soccer, netball nor volleyball. The number of learners who don't play any sport is E. They normally put it like outside like that. Okay, sharp. Now let us get into this. We're gonna find all of these numbers. We're gonna find the value of A, B, C, D, and E. Ne? Okay, let's just ignore the questions. Let us do it ourselves. Let's just ignore the questions and just find out. Okay. You start at the intersection. You start here. They say one learner plays all 3 sports. This makes sense. It's there. Okay, we're happy. Sharp. And then it also says let's look for this intersection here. This one. The intersection is the number of learners who play both soccer and volleyball. Let's see if we've got a statement where we've got soccer and volleyball. Yes. So here's a statement. 2 learners play soccer and volleyball. So that means this must be 2. Do you guys agree with me? So do you guys agree with me that this must be 2? So that means I'm gonna go b plus 1 equals 2. Are we together, class? I'll repeat. They say 2 learners play soccer and volleyball. So which is this part here? And this part is b and 1. So we're gonna go b plus 1 equal to 2. Are we all happy? So we're gonna make b the subject, so therefore b will be equal to 2 minus 1, which is 1. Happy? Now, let's see if we can't find a. That is, let's highlight it, sorry. Let's see if we can't find a using the intersection of soccer and netball. Let's see if we are told the number of learners who play soccer and netball at the same time. Let's see if we are told that number of learners who play soccer and netball at the same time. We are not given that. However, so we've got 1 here. Remember that b equals 1. We are told that there's a total of 55 learners who play soccer. So it means 55 learners who play soccer. We are referring to what? We're referring to this. 59 players, learners play soccer. So it's A plus B plus C plus the 1 must give us 55. Do you guys see? So we don't have the A, that's fine. We have the B is 1. We don't have the C. So we have that A plus C plus 2 equals 55. We know that A plus C equal to 55 minus 2 gives us 53. Are we together? Please confirm if you understand. Please confirm if you understand. Ngosnati, are you following? Amo, are you following? Okay. So the internet, sorry, not the internet, but the network was cutting a bit. Let me just quickly re-explain this. You guys got the first part, right? Okay, you guys got the first part. Okay. So we're gonna do this, to make it easy. So we already found the value of B. Now we're looking for the value of A, C, and D, and E. Okay. I think the quickest way to go about this is this one here. The number of learners playing netball. Ne? So they tell us that the number of learners playing netball is 21. Ne? So it's 21. So it's A plus 1 plus 2 plus 3. So A plus 1 plus 2 plus 3 must give us that's 21. I get that's 21. So if 21 equal to A plus 1 plus 2 plus 3 gives us 6. Then we take the 6 to the other side, it's going to be 21 minus 6. Therefore, A will be equal to 15. Do you guys agree with me that A is then equal to 15? Easy peasy, ne? Sharp. A equal to 15. Let's move now. So we've got A equal to 15, B equal to 1, then we can find C. Okay, let's clear this. We have established that A equals 15, B equals 1, then we can find C. How are we going to find C? We're told that the total number of learners playing soccer is 55. So which means A plus 1 plus B plus C must give us 55. Okay, so A plus 1, this one, plus B, this B, plus C, this C, must be equal to 55. We already have the value of A is 15, the value of B to be 1, the value of C is what we're looking for. So on the right, on the left hand side, we have 15 plus 1 plus 1 gives us 17 equal to 17 plus C equal to 55. Are we together? Then we have C equals 55 minus 17. What is 55 minus 17? 38, ne? proper stuff. So therefore, C equals 38. Okay, and then C is literally the number. Let me highlight it. C is the number of learners playing soccer only. Do you guys see? Sharp. Let us then find the value of D now. We've got the value of B to be 1. So let us find the value of D. D falls under volleyball. How many learners play volleyball in the school? We've got 7 learners who play volleyball in the school. So it means that the 1 plus the 2 plus the B, which is that, plus the D equal to 7. Okay? So we substitute 1 plus 2 plus our B is 1. Our D is what we're looking for. 1 plus 2 plus 1 is 4. Then D will be 7 minus 4, which is 3. Are you happy with the value of D being equal to 3? Okay, sharp. Then let's move. Let's look for the value of E now. So our D is 3. Let's put 3 there. Our B is 1. Okay, our A is 15. Okay, now we're looking for the value of E. Now we know that A plus C plus B plus 1 plus 3 plus 2 plus D plus E gives us a total of 100. Remember, the learners are 100 in the school. So we're going to go, A is 15. Let's write in pink. B is 1. C is 38. D is 3 plus the 1, the 3 and the 2. 1, the 3 and the 2 plus E must all give us an answer of 100. So let's go 15 plus 1 plus 38 plus 3 plus 1 plus 3 plus 2. How much does it give us? Quickly. It should give us a value of 63. When you add all of them. Remember, I literally added everything. I added this with this, with this, with this, with this, with this, with this, and this must give us a total of what? 100, as mentioned in the opening statement. So it's going to be 63, and then therefore E will be equal to 100 minus 63, which is how much? Quickly? 37. Eh? So therefore, the number of learners who don't play soccer, netball, nor volleyball is 37. Happy. The whole class is happy. Tano, are you happy? Tsapang Khweng, are you happy? Mohadi, are you happy? Sijo, are you happy? Yes, 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 yes. We're all happy, all happy. So, sharp. So this is the E. Let's do the last question. So it says, what is the probability that one of the learners chosen at random from this group plays netball or volleyball? Ne? Probability that you choose a student at random from the school. What is the probability that the learner plays netball or volleyball? And I told you that the classical probability is probability of A or N will be probability of N plus the probability of V, so this and this, ne? Minus the probability of N and V. Okay, let's go ahead and find it. What is the probability of N? What is the number of learners playing netball? It is this whole thing, ne? Number of learners playing netball, it is 21. You put 21 out of a total of 100 learners, plus probability of learners playing volleyball is 7. So put 7 there over 100 minus what is the probability of learners playing netball and volleyball at the same time, the intersection of netball and volleyball. So it is this netball and volleyball. It is 1 plus 2, which is 3. It's also mentioned where? It's mentioned somewhere. Is it mentioned? Not really. Okay, so we've got 3 learners. So 1 plus 2 is 3. over 100. Please calculate this thing for me. Please calculate this thing for me. Tell me the answer. Zero point what? 31, eh? Something like that. Is it 0.31? Please confirm. Please confirm. Please confirm. Please confirm. It is 0.31. Yes. Sharp, sharp. So that is probability. So this will be our last class on probability because we've been doing probability over the July holiday as well. So I trust that you guys understood the whole of probability. That is all of this independent events, mutually exclusive events, complementary events, and the Venn diagram itself. You guys understand how to sort of construct like values, that is intersections and so on Venn diagrams. Let us meet again same time tomorrow at 5 o'clock. Thank you, Tano, for attending. Sapangweng Amogelang Kusnati Katlego. Thank you, Mohadi, and yeah, all of you. Thank you so much for joining. So you guys remember that today I had the session on both Microsoft Teams and TikTok. So on the last week of every month, I always do this. So I held these classes on Microsoft Teams and TikTok so that people on TikTok can see what we offer. So this is the only time I give sessions on TikTok. If you want to join on a full-time basis, you're free to send me a WhatsApp on 0637849428 so that you can join us on a permanent basis. We have classes available for grade 8 to 12. Feel free to send me a DM on the given number or even a DM on the TikTok profile itself. So guys, let's meet again tomorrow at 5 again. All happy? The class is recorded. I'm going to share it within the next 24 hours. Yes, I'm going to share it within the next 24 hours on TikTok and YouTube. Thank you so much. God bless you and your family.